Okay, I think this is working. We'll see. We'll try this. There we go. Do your thing. All right. Now, I'm hoping this is, relatively simple for us at this point. To attack this, we're going to do the conjugate. Keep that in mind, conjugates to unlock square roots. And that's just going to turn this thing into this. Just like we saw in the last quiz. I think this exact question was on that last quiz. Okay, right? Multiply the conjugate. What do you got? You writing stuff down? All right, good. All right. Scare me for a second. All right. These cross out like we knew they were going to, leaving us with a 1 in its stead up here. And then you plug a 3 in, you get 1 over root 3 plus root 3, which is 1 over 2 square root 3. Easy enough? Am I know what we just did there? What's up, Omar? Okay. Good question. So it's 1 over root 3 plus root 3. The question is, why is that not root 6? And the reason is, like, roots just don't work like that, dude. So think about this. If it was 1 over x plus x, that's 1 over 2x, right? Those root 3's are the same thing. They're just numbers, like x is. Okay, so root 3 plus root 3 is 2 root 3. You can't add, roots do not play nicely with addition. They just don't. All right? So like if we had something like this, what's root 5 plus root 2? That's just what that number is. Root 5 plus root 2 is just that. Cool? Multiplication with roots works out super nicely though. Like root 5 times root 2, that works how you want it to. That's root 10. Okay? All right. Now, what did we just do down here? What is this question asking me? Anybody? Any takers? Okie dokie. This is what we just did. This is what the square root of x looks like. If I picked x was 3, the point that I would have there is 3 root 3. Okay? If I picked any other point on that curve, but didn't give it a x value, just called it x, we'd have that. What is this in this box down here? What is that? Root x minus root 3 over x minus 3. Really? That's a y value minus a y value over x minus x. Since like pre-algebra, you've been doing this. What is that? That's slope. Thank you so much. That's our fancy word. That's the slope. That's the slope from this point here to this x point that I have. And as I bring x infinitely close to 3, that brings this point back to here. That doesn't find the slope from 3 to x. It finds the slope at 3. So the slope of root x at 3 is that. That's what we just found. Okay, that's all. If you zoom in on it, that's the slope it has. All right. Let's get rid of that. This one, everybody knows, is going to become 4 minus x over x minus 4 times 4x. We're all there. And again, you can do it in your head, I'm hoping, but that's just us multiplying by these 4x's here. These are going to cancel out. They leave a negative 1 because it's reverse subtraction there. And that gives me negative 1 over 16. Okay? What did we just find there? What did we just find there, Mason? The slope of what? Slope at, so it is that, but the slope of what function? 1 over x, dude. That's a function, that's a y value, right? 1 over x. So that's the slope of 1 over x at x equals 4. Okay? All right, now, let's come out here. We're going to do the same thing a couple times here with this, and I'm going to show you a little shortcut. All right? So, we're talking about this right now. Cool. Here's the graph of this function. I graphed it for you. I did all the hard work. There it is. It's a parabola opening upward with a vertex at 3, negative 9. Okay? If we want to find the slope at 5, how could we do it? The same way we just did. Okay? You see the point at 5 is right here. That point is 5, negative 5, right? You find negative 5 by plugging into the function. You can all see it is negative 5. And then we need another point on that curve, but we don't want to pick just any point. I don't want the slope between any 2 points. I want the slope at 5, negative 5. So the point I pick is going to be a variable point. Now, even though I'm putting it up here at like 6.2 or something like that, we're not going to say that. We're going to say this is x. What's the y value there, Shea? No. So remember, I put that point there, but I can put the point over here and call that x. It doesn't matter where I'm drawing it. But if the x value is x, what's the y value? How do we find the y value? Always. If I told you the x value was 3, look at the function. That's 3 squared minus 6 times 3, right? That's a 3. You all see what I'm saying? So if the y value, or x value is x, what's the y value, dude? No, you don't like that? If the x value is 3, this becomes 3 squared minus 6 times 3. If the x value were 8, it would be 8 squared minus 6 times 8. If the x value was sad heart, oh no, sad heart, it would be what? Sad heart squared minus 6 times sad heart. And the fact you did that correctly means these aren't sad hearts, they're happy hearts. Oh. Okay? Whatever's sitting there, there you go. Whatever's sitting there is what gets plugged in. So if my x value is x, what's my y value? X squared minus 6x. Yeah. That's what that function is, right? It's just you plug it in. It doesn't matter, guys. I can make up any stupid symbol I want. Math has all kinds of crazy symbols. All right? We're using x's for right now. That's what that is. Great. Drew Young, what's the slope between those things? What's the slope between those 2 points? Yes. y2 minus y1 is? What? Guys, I don't know if my hearing is going. Are you whispering to me? What? Okay, why would it be x minus 1? So you've already done it and canceled it out. That's not what I want. I want the whole slope. You're right. That is correct, yes. But you're way ahead of where I want to be right now. What's the formula for the slope between these 2 points, dude? y2, which is? Yeah, so what is that? From this particular question. Word, minus negative 5, but that's just plus 5, right? We all know that. Over what? X minus 5. And that's the slope from the point here to any other point on there. Again, I drew it there, but it just as easily could be over here. Right? It can be anywhere. X can be any number. Yeah? But I don't want the slope between 2 points. I want the slope at 5. So what do we put out front? We put, hey, what happens as I bring my second point, my x value, infinitely close to 5? That's what that says. You good? You see how this factors? How's that factor, Robert? Come on, baby. Cool, so those are numbers. What are the factors? Cool. Not x minus negative 1. X minus 5, right? So negative 1, negative 5 go with the x, right? But it's x minus 5, x minus 1. Cool? You good? Boom. And like we've seen over and over again, we knew the 5s had to cancel. Or the x minus 5s had to cancel. When you plug into that, you get negative 4. Julius, what's that negative 4 mean, bud? Yeah, the slope at 5 is not negative 4. Why did I say that? It's positive. We all know that. Positive 4. Come on, yell at me. Y'all okay? 5 minus 1 is 4, not negative 4. Okay? I was thinking ahead of my next question. But you can see here, it's kind of hard to see. But if you draw a line here, you with me here? Over 1, up. Like that right there looks like the slope of that curve. You see that? That's the slope of 4, kind of? Not kind of. It definitely has a slope of 4. That we just proved it. Okay? That's what we just did. And you're like, okay, who cares? Told you rates of change, very important concept in so many different things. All right, now I know what you want. You want to find the slope at 3 and at 1. So go ahead and do that. I want the slope at 3, I'll write it up here, and at 1. So here's our function. We're going to find the slope at x equals 3 and the slope at x equals 1. Two separate questions. Go ahead. If you're playing along at home, watching this, good for you. I'm going to pause it. You should pause it. Try it out, really. All right, we're back. Here we go. I can't believe that happened while the video was paused. That was crazy. We should have discussed something we said. Crazy happened. Okay, anyway. Yo, the point we're talking about is 3 negative 9. Ay. Any other point, I'm putting it here, but it doesn't matter. Boom, 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 boom. And we should have got x squared minus 6x minus negative 9 is really plus 9 over x minus 3. Here we go. Right? But we know that numerator factors into x minus 3 squared, which is just x minus 3 over that x minus 3, and they cancel out. When you plug a 3 into that, you get 0. And I know you don't like 0 as an answer. You're like, what did I do wrong? But 0 is the answer here. The slope of that curve at 3, negative 9 is 0. You can see it right here. It's flat down there. Okay? Good talk. I also said the slope at 1, but look, the slope at 5 is right here. The slope at 1 would be over here. See how they're like mirror images of each other? If the slope over here was 4, what should the slope over here be? Negative 4, thank you. Yes, it should be negative 4. The slope at 1, let's go ahead. Look, it'd be the slope as x approaches 1. The y value there is negative 5, so it becomes this. That's how you set that up. Because again, this point over here is 1, negative 5. We're just finding the slope between that and our variable point, which has been x squared minus 6x. So y2 minus y1 over x2 minus x1. You can see what's going to happen here. This factors. And you plug 1 in, you get negative 4, which is what we expected. It's like it works. I can't believe it. Okay? Now, we're going to ramp up a little bit. We're going to kind of take this back instead of choosing numbers here. We're going to make it a little more variable, I guess. Less concrete. All right, so anyway, we're good with these. We got 3, we got 1. Here's our question right here. What if we wanted to find the slope at any point? All right? At any point at all. We did 5, we did 1, we did 3. If I asked you to find the slope at 10, you can do the same thing. We can keep on doing this over and over again, right? Okay? But it turns out, let's go back up here. If we want to find a formula for this, instead of having to find the slope over and over and over and over again, if we want to find a formula for the slope, think about this. Then we can't choose an x value. Now I know I'm drawing that point right there, gang, but it could be anywhere. It doesn't matter where that point is, okay? I'm going to call it x squared minus 6x, where this value up here is x. Can we handle that? Let me see if I can do this. Look, it doesn't matter where the point is. It could be anywhere. It could be up here. It could be down here. See what I'm doing there? X value could be anywhere at all. All right? The y value will always be x squared minus 6x. Cool. I'm simply choosing it to be like over here somewhere. It doesn't matter. Boom. Everybody okay with that? Yeah, good. But to find slope, we need a second point. And here's what I'm telling you. We can't choose like an actual number, because once we choose a number, like I did for 5, that locks me into the slope at 5. I don't want to choose another number. So what we could do is choose another letter. Ready? Like I could choose, hey, this x value up here is a. What would the y value be there? Brain, what would the y value be there? Thank you so much. A squared minus 6a. Right? And we can find the slope between them. Cool? But most of the time in a calculus class, they don't write it like this. They write it like this to make it look a little complicated, but you'll see why. Instead of calling this x value up here x or a or anything like that, they call it x plus h. All right? The reason, look what we're doing here. If this x value here is x, let's think about this number line over here. If this is x, and I say this is x plus h, what's this distance here, guys? Do you see that's just h? That says, hey, I took x and I added a little bit to it. Is that all right? That's all that means. Cool. And in that way, our points are kind of linked together by this h idea. Who's with me here? If that's the x value, what is the y value? Jelly, what's the y value? If whatever's here goes squared minus 6 of those things, right? So if this is x plus h, what goes here? Yes, ma'am. X plus h squared minus 6x plus h. Anybody not okay with that? Just plug it in. That's it. Keep in mind those parentheses. All right? When you sub something into a function, it gets parentheses around it. All right? Now, let's erase this for a second. I see you over there, Lily. What's the slope between those 2 points? Say it loud. Say it proud. What? Yes. Cool. It's not x plus h squared, right? It's x plus h. And I purposefully missed one thing. What do I need here? Anybody see? What? Parentheses. Yes, ma'am. Thank you. Yeah, it's minus the whole y value, like that. All right, now let's color code this thing for a second. Here we go. Come here. Draw. Let's choose blue. That's a nice color. This here, that is y2 minus y1. Y'all see that's all that is. This is x2 minus x1. That's that. That's all we did. It looks complicated. There's a lot of junk going on in there, but that's just a y value minus a y value over an x value minus an x value. All right? What does this big, nasty looking fraction represent? The slope from any point to any point on that curve. Okay? But remember, I don't want the slope from a point to another point. I want the slope just at x. Okay? So let's think about that again on a number line, which is right here. Look. Here's x, and here's x plus h right there, right? What do I need to happen for this point to move back towards that point? Think about this. What should happen to h? Do I want h to be big? If h is big, are those points close or far away? Hello, there's one of me. There's like 15 students in this class. 10, I don't know here. If h is big, are those points close or far away from each other? Far away, thank you. Why? Far away, yes. Far away. Okay? I want them to be infinitely close, super close. So I want h to go where? What's going to bring... Talk to me, kids. If this is h, right? That's the distance I added to get there. I want to move this to here. What should happen to h? Where should it go? Oh my. Huh? It should go left, yeah, but to what number? What about h? H was 1. Are the points close together? What if h was 0.1? How about 0.01? How about 0.0001? If h becomes really tiny, where do I want h to go? To 0. I need h to become 0, and those points overlap. Now, we don't want the points to overlap. We want to know what happens as it approaches 0. What is this going to find me? The slope where? Anybody? Anybody with me though? This is the slope between 2 points. Yes? X and x plus h. If h goes to 0, now it's the slope between what and what? If it's the slope between x and x plus h, and h becomes 0, what is it the slope between? X and what? It's x plus h. I hear you. It's not 0 though. It's x plus h. What does that become when h becomes 0? X plus 0, which is x. As we let h go to 0, that becomes the slope at x. It's the slope at one x value now. That's what's going on. Okay? But it looks like a mess. But here's my 100% guarantee promise to you. You ready? Every time we do this with the x and x plus h thing, h is going to cancel out. H has to cancel out for the same reason all the other junk had to cancel out before. Let's think about this. If I plug 0 into this thing, think about this. If I put 0 in for h, not for x, h, there's two variables. X represents any x value I want. H is the distance between my two x values. If I put 0 in for h, do you see that this becomes x squared minus 6x here, right? You see that? Minus x squared plus 6x. That's what the whole numerator becomes. What is that? That's, hey, there we are, some life. That's 0, right? What's the denominator become when I put 0 in for h? 0. And what do we say about this mystical 0 over 0? When we get it, what has to happen? Something has to what? Something must cancel. Something must cancel. Okay? And not just something, h minus what I plugged in. Remember we said that? Like, remember up here? Look up here. Boom. Remember we did this question? When you plug in 3, you got 0 over 0. That means x minus 3's had to cancel. When you plugged in 4, you got 0 over 0. That means the x minus 4's had to cancel. So when I plug 0 in for h, and I get 0 over 0, what has to cancel? Not x minus 0, I plug in 0 for h. Not x. What variable are we plugging for? H. H minus 0 is going to cancel. Do you see this? But what's h minus 0 really? That's just h, guys. That's h over h, right? That is going to cancel out every single time here. Every time. The bottom's easy. What happens to the bottom right away? You guys see what that is? That's just h. It'll always just be h when we do this. Because x plus h minus x will always give us h. The numerator requires a little bit of work, but not a ton. Look, all we're going to do is expand this out. Check this out. Do you guys know what x plus h squared is? Fun fact, it's not x squared plus h squared. That's incorrect. Squares don't work like that. That means you need to FOIL it like this. It's this. Y'all can FOIL, that's what that is. Minus 6x minus 6h. Do y'all know what this is here? What is this? You see it? That's that. Minus x squared plus 6x over h. Again, to be super duper repetitive, and h is going to cancel out. You see there's an h on the bottom already. That means we have to be able to factor an h out of the top. All right? We have to be able to factor one out. But the only way that can happen is if everything up top has an h. Cool? Right now you see up top there's a bunch of stuff that doesn't have an h. Here's again another promise guarantee to you. Everything without an h in the numerator is going to cancel. It has to. If it does not cancel, you probably miss parentheses or something. Okay? Let's go ahead and let's see what's up here. It looks like a lot. We're going to do much bigger stuff than this. By the end of the year, you're going to be like, this is baby stuff. Look, this doesn't have an h, but then you have this back here. You see that? This doesn't have an h, but then you have this back here. They cancel out. So the only stuff that's left up top is 2xh plus h squared minus 6h over h. Oh my goodness, look at it. And now everything left up there has an h, okay? Again, another very common algebra mistake students make is they see an h squared and an h and they try to like cross those out or something. You cannot do that with fractions because of this plus and minus. You need it to be multiplication to cancel. Okay? So if you see what's happening, you can cancel out an h here, here, and here. Or, if you don't like that, what's really going on is we're taking an h out of here. Ho, ho, ho. That's what we're left with. How are we doing? Y'all see that? We took an h out of there. And now that it's h times all this junk, divided by h, guys, you do not have to write it like this. I'm just showing you. I feel like we don't understand sometimes, like what's really going on. That's really just this. Do you see this? That's the same thing as that. Because this is really over 1. Like multiplication and division fractions like this, they work super nicely together. They pull apart. Okay, it's like a fun toy. Okay? The h's cancel out. You don't need to do that. You can just cross them out right here. All right, just know they cancel out because of that. And if I put h equals 0 into there, after all of our hard work, we are rewarded with 2x minus 6. There you go. Now, CC, what does that tell me? What's the point of that? Why does it exist right now? What? Oh, true. It tells me what that whole big nasty fraction would be as h goes to 0. True. But what was that big fraction finding in the first place? The what? The slope of that function at any x value. Okay? Like it was born from that function. It was derived from that function. Much like you were all derived by your parents. Yeah? Okay? You know what I'm saying here? Yes? You guys are like the derivative of your parents. Not really. Okay. But this thing's called the derivative. It was derived from that function. Okay? And it tells us the slope of that function. Let's double check. The way we denote slope, check it out. If f of x is x squared minus 6x, to say, hey, find the slope at 5, you write it like that. That's read as f prime of 5. That's what that says. It says find the slope at 5. But if I put 5 into this formula, what do I get? You come here. You see this? You get 4. But remember we did it the long way back in the day? Like when you were younger? Like about 20 minutes ago? And we got 4. Remember we did that? And the slope was 4? There you go. Remember we found the slope at 3? The derivative at 3? What did we get there? Do you remember we did this? You didn't like it, Shaya? Because it was like, oh, I did something wrong? Yeah? It was 0. What do you get when you put 3 into our formula there? 0. Oh my God, it works. Remember what we got when we found the slope at 1? -4. Now I have a formula for the slope anywhere. Cool? So if we had found that in the first place, we would have had to do all that work to find the other slopes. We just plug right into that. And later on, I'm going to show you how to jump right to this formula without having to do all that h go to 0 stuff. But before I do that, we're going to practice this a little bit just to get our algebra skills down and make sure we're okay with this and just to recognize this pattern. Okay? Okay. So on this page here, I'm going to change the numbers on here. All right? I got a bunch of functions and I'm saying, hey, do this. But what I'm really saying is find the slope formula for these functions. But no one calls it slope formula. You don't want to go to college and say slope formula. I think you're a weirdo. You want to say the derivative. Okay? People are going to think you're weird enough already at college. Trust me. I'd love to reach you. Come on. Yeah, okay. It's hard. Yes, Omar. So, even if you know the shortcut, Omar, which I know you do it the long way and make sure it works, okay? Okay? So if you do know the shortcuts, you can check your work. That's nice, but you should still do it the long way to make sure you can do it. So let's go ahead and do number 1. All right? I'm asking you to find the slope of that function at any x value. Okay? I'm telling you, slope for us always comes from the basic idea of it, 2 different points, change in y over change in x. The first point for number 1 is x root x plus 2. I don't want to choose a number, okay? If I said find the slope at like 6, then you could put a 6 in there if you wanted to and use that as your point. We're finding a formula for the slope anywhere. My other point, again, we're going to choose our x value to be a little bigger than x. X plus h. Ho-ho! Bryn, what's the y value going to be if x is x plus h? If the input is x plus h, then the output is the square root of x plus h plus 2. And technically, we should put parentheses around that x plus h. They don't matter in this particular case, but you could use doing that. And then all we do is find the slope between them. Okay? So that's going to do it up here. That is the square root of x plus h plus 2 minus the square root of x plus 2 all over. We know the denominators, hopefully we know this, x plus h minus x, right? What's that always going to be? Well, you can write this, but every single time that's just going to become h, which is why there's just an h down here in this little formula. Okay? And now we have the limit as h goes to 0. And then all I got to do is simplify it the same way we've been simplifying when we see a square root in the numerator, or denominator really, but mostly the numerator is what we see here. Robert, what are we going to do here to unlock that, bud? We've got to multiply by something. What's that called? Okay, well, we can't square it. We got to multiply it by something that's going to square both of them without changing really, or give us any of the square roots. What's it called? Yeah, what's it called, Shay? It's not its inverse. It's conjugate. Yeah, it's conjugate. All right, it turns a minus into a plus. Okay? So something you'll hear really smart people say when they're in a bad situation is they'll say, we need to conjugate this situation. No one says that, but you know, the minus becomes a plus. You see what I did there? It's good. Okay, here we go. Root x plus h plus 2. We've got to multiply it in the numerator and the denominator. And that looks like a mess, but everybody knows what happens when you multiply conjugates. I'm going to write it right down here. It squares the first thing, so that just becomes x plus h plus 2 minus it squares the second thing. That becomes x plus 2. What am I forgetting? What? Parentheses. It's minus the quantity x plus 2 over h, that's what was left there originally, times this whole big nasty mess. Don't worry about how that looks. Remember our goal here. Cancel out h. All right? That's our mission. Look what happens up top. We have x minus x. We have 2 minus 2. Right? This is plus 2, but it's in parentheses, right? Negative distributes there. So the only thing left up top is really h. Isn't that nice? I think it's nice. You know what happens to those h's? You see how it's multiplication here? They cancel, leaving us with a 1. And if you plug in, h is going to 0. You get 1 over root x plus 2 plus root x plus 2. But Omar, what are we going to say that equals, bud? 1 over 2 root. Cool. No, it's just x plus 2, man. Wow. Hey, hey. What does this find me, Julius? What's the point of this? Slope of what function? Of root x plus 2. It finds a slope anywhere of root x plus 2. That's all it does. So look, for homework, I'm going to change the numbering on this. I want you guys to do these 6. I already did the first one. Okay? Try those out. All right. Good work today.